Thanks for participating today. Today's webinar is on energy and sustainability ERP for automotive manufacturers, with a big focus on how the tools of an ERP can help manufacturing lines. Briefly to start, to introduce who we are EnergyCAP, and we provide best-in-class energy and sustainability ERP software, ERP being Enterprise Resource Planning software, with a big focus on energy and sustainability reporting. Over 10,000 energy and sustainability users are logging in every day and accessing our platform, tracking over $17 billion worth of vendor utility bills and verifying hundreds of millions of dollars worth of energy savings year to year. The main value of our ERP is we allow data, energy and sustainability data to come into the platform, and then you get value out of it on the back end. And it's a better way to help you manage your consumption, reduce your carbon footprint, and help to drive energy savings. The energy and sustainability ERP is a single source of truth for all of your energy and sustainability data. It is financial grade reporting of your carbon data, your usage, your demand, and your cost information when it comes to energy and utilities. We have 3 different modules within the framework of the ERP. I will touch on all of them today, in fact. The first one is what we call Carbon Hub. It is financial grade greenhouse gas accounting and carbon reporting. So this would be helping you with your ESG reporting initiatives and tracking your carbon footprint in your quest to reach net zero. Then there's EnergyCAP utility management, which is focused and centered around utility bills. And this helps you get your arms around all of the utility bills that you'd be receiving from your utility vendors for all of your facilities and help give your data life. And then lastly is Wadix, which is a smart analytics platform that lets you look at your data in real time so you can make actionable decisions and take actions immediately with alarming and alerting for when there's problems potentially on your lines, your equipment, zones in your buildings, any one of those kinds of things. And then kind of over encompassing this are some services to acquire data and process it. So very specifically for the automotive and manufacturing industry, there are tools that provide cost optimization. So there's tooling that lets you do a deep dive into the production lines and helps you track efficiencies, and then run some optimization activities to see what you could reduce from a usage and cost standpoint. Doesn't have to be limited to production lines. It could just be in pure usage within the buildings. But the whole idea is to monitor, important assets and important parts of the building, so you can take action and make informed decisions. The next part of this is energy efficiency. It allows you to quickly detect equipment and facility issues in real time, so pinpoint problems. And then once you pinpoint problems, and you can even run some cost optimization activities, you can then run the M&V, or the measurement and verification of savings, after you've implemented projects. And then last is getting your arms around greenhouse gas reporting, carbon reporting, and carbon accounting. So this can help you track the carbon values of what you're producing. It can track the carbon values of what you're purchasing, what you're consuming. It's tracking. It can track all 3 scope types: 1, 2, and 3. So how is this played out in real time? And I want to give you a success story of one of our clients, just so you can understand some of the capabilities. So what we have is a manufacturing company that has some very important pieces of equipment, some die cutters that are used to cut various shapes, in large scale in an industrial environment. So what they found once they started to do a study was just that they didn't think that their pieces of equipment, that they're really important, high intense usage pieces of equipment were functioning properly. But the only way to really understand the behavior was to meter it. So what they decided to do was to buy some hardware and then monitor various points of the process. And then this would allow them to first get exposure to what was going on, so then they can start to, make some changes and then track savings. So by metering and then putting all of that meter data into our platform, they did find that a vacuum unit was left on when really their process was not even operating. So they have some of the machine was just operating at basically full capacity and not cycling and shutting down in between cycles whenever there was not even a job running. The machines were left in idle mode over the weekend. So machines were just idling over the weekend instead of having deeper setbacks. And a lot of these things are just problems where the machine was not configured to operate most efficiently. So they started to change some of the patterns and behavior and schedules of the machinery to be more efficient. So you can see the chart over to the left where they found there were periods of idling where let's have deeper setbacks. And then once we have a job, we can ramp up the machine and be operating in full capacity once we're actually, the machine's doing its work. But then as soon as we're done, let's, set back the machine and just have some deeper setback until the next job needs to start. So there was some setbacks, and then you have the new job, and then you get back to an idling phase when you're kind of completed either for the day or for that cycle. So by just getting exposure to the data and then running some new cycling, they were able to realize some savings. So what you're looking at here was in the first 6 weeks of just monitoring the usage and the patterns, they started to realize that they were operating most inefficiently during the day, but even at night, because things were operating and idling at night when they shouldn't have been. So now that they had better exposure to the data and were able to make those changes, they saw a 50% reduction of electricity costs just over the next 11 weeks. They had an ROI within 1 year real quickly. And really, there's a lot of value in getting access to interval data and getting access to how your machines are cycling on and off, because there's generally some pretty quick payback because you get some better insights. You get better insights of what's going on in real time. And so then you can start to make some behavior changes. But you also need the means, the tooling to be able to track it, analyze it, and then make the changes and then report the savings. Side note on this too was while they did get a 50% reduction in cost, that also translated to a reduction in the CO2 emissions as part of their line. So really by reducing their consumption and cost, they can also reduce their CO2, and we're able to report on that. So really it's a win-win-win all around. And those are the types of tooling that the EnergyCAP ERP brings to the table. So let's see this in action. Okay, I'm now in one of the applications that does smart analytics. So this is looking at interval data. And over to the left, you can lay out an organizational structure. So you can have different business units, different regions. You get down to a building, and then underneath the building, you can monitor different types of points. So you could have monitor large pieces of equipment. Underneath the pieces of equipment, you can also nest subpoints to the equipment that you would be tracking. So it's real easy. In this case, in the middle, I'm showing analytics, and then over to the right, filtering. In this case, while this client is monitoring all the subpoints, in this case of their HVAC unit, we can easily roll up HVAC as a whole so you can look at the profile. So this is July 26th. This is today in live, real-time, monitoring of this point. I could then click on any one of these subpoints, so the air handler unit or the air compressor, and just get details about that individual monitored point as well and see how that has been performing today. So you can track large pieces of equipment, you can monitor subpoints, you can track just a building as a whole. You can also track some other things like, gas and thermal meters. You can track other types of metrics like indoor air quality, so CO2 and humidity and ozone and temperature. You can also track production. All of these things can be tracked as their time series data. So the platform allows you to track time series data and put a unit of measure to it, and then analyze it and dissect it a lot of different ways, okay? So realize it's not tracking just consumption, but a lot of other variables as they relate to your performance in your manufacturing plant and the metrics that are important to you. Okay, so what we can see here is when we click on a point, I can get to look at some data. I can, over to the right, this is all filtering. And so if I wanted to look at, say, weekly data, I could click on the weekly tab, and then this rolls up to the data over a week, over a month, and whatever time period I want. The system, in this case, is tracking demand, or KW. It can also bring in other factors if you are metering those factors. So in this case, power factor or voltage and current and other variables that you would want to bring in as they relate to power quality. Okay, so the system can track a lot of different details. Now, as this data is coming into the system can connect to meters that you have installed. They can connect to gateways. We can connect to BAS, BMS, SCADA, other types of metering and data warehouses. We can recommend hardware if you don't have any. And we're basically system agnostic. We can connect to all different kinds of hardware, sensors, gateways, and systems. So as this data is flowing in, you can set up alerts to highlight any type of issue. And there's really three major types of detections. The first one is an offline notification. So what this is doing is allowing you to say, well, if data is not coming in, send me an email. And if I don't receive reads within a specified time period, let me know about it. And that's really important to ensure that data is flowing so it's always current. The next type of notification is based on a custom threshold that you set. So you can pick any point in your system and either alarm against a threshold or accumulation. And then you can set the parameter based on what you're metering, and then say what the threshold is, what time period you want this to alert you in between. So you might want to have some alarms during working days and hours, and maybe some over non-working days. But you set the criteria, it's all customizable, and then you define how the system alerts you. Put notifications on a dashboard, send you a text, or send you an email, or all of the above. And then the last type of notification is based on machine learning capabilities within the system that we call Sentinel. So this is just saying, you know what, system, you determine what is a reasonable load and profile for every point, and then alarm and alert if it falls outside of that. So this is a really nice capability where any one of your points, this is an air handler unit, it creates a profile, which is in green, and then it charts the actual in black. So this is today data. You can see the air handler was a little bit outside of the Sentinel. So I can set up alarms to say, like in this time period, send an alarm because normally my air handler unit is getting a setback, at the lunch hour, and today it was operating as it might not be expected. So every one of these points has a different profile. Just depends on the common use, days of the week, seasonality, things like that. So you can see here, now maybe in this case, there used to be a scheduling issue where the boiler, was operating heavier during the evening, and then it shut down at like 3 in the morning, and then at 4:30 in the morning, it starts to turn on, and they maybe change the schedule of this. And so maybe this is the new schedule. Just because something changed doesn't mean it's necessarily a problem. In this case, it might be that the facility manager is saying, well, like, we don't like how the profile has been operating. We want to change it. And so now they're working on, deeper setbacks in the evening, and then a more consistent ramp up at 6 or 7 in the morning. But what this will do is give you exposure to what the historical patterns have been, and then you can start to make changes. And then over time, this will start to learn those changes and change the profile. Now, how this looks in practice, if I go to a home screen, I can set up live dials of data. So there's a lot of widgets and configuration that every user can set up. So this is just showing some live data points. But then down below, it's telling me of any of these types of notifications or alarms that the system detected. So these are all of my unread alarms, and I can see when the event occurred, and we can even put an expected dollar amount. So this is in euros, but it could be any currency that you need to track. And it's telling me that for 20 minutes yesterday between 5:40 and 6, this point operated higher than expected, and so it might have cost me €3 because of it. And if I want to see what that event looks like in my Sentinel, I can go back and see, like, yeah, sure enough, this was turning on a little earlier than it normally does throughout the day. Again, in this case, it could be a problem. It might be, it might not, but it at least gives you the details that it's an anomaly compared to the expected pattern. Okay. Some other capabilities in the system, really important for production lines, where there's a whole analysis engine that lets you compare points with one another. So what I have highlighted here, this is 1 day's worth of consumption data. This is of HVAC, but it could be of a production line compared to my production. So in this case, what we're saying is, well, I want to compare, how does my usage compare versus my production? So I can get an understanding of what that looks like. There's a lot of different ways to chart the data. Maybe I don't want a bar chart. I want a line, overlaid like this. I could also do a stack bar, and just a lot of other ways to look at the data. So you can do comparisons a lot of different ways. So in this case, it's, again, looking at your production, so units produced per kilowatt hour. Maybe what I want to do is just compare a bunch of points one on top of the other. So in this case, it's all of the components that feed the HVAC. Again, these could be points within a manufacturing line or piece of equipment. And again, I can see how do they all stack up to the total. In this case, it's 5-minute data that I'm looking at. So I can see in the aggregate for the day, it's roughly 3,900 kilowatt hours. And then how each one stacks up, one on top of the other, and how they all influence the total. So a lot of different ways to chart data. Some other things you can do is you can overlay, you can run overlays. So what I have here is some of the shading. I'm overlaying hours of operation. So let's say I go back to my comparison of my use versus production. Maybe I also want to overlay and shade various hours of operation so I can see just how are things operating when I know I should be open and at capacity and operating. If you have some higher consumption during off-peak times, you might want to note that and highlight it. So let's say I have an issue and I want to note it. There's the note capability in the system where I could say, hey, maybe Allison is one of my operators. And I could say something like, why is HVAC running from midnight to 2 a.m., right? Because if you see this period here, it's like HVAC was running and maybe, my building wasn't operating. It was shut down. So I can list that, note this to Allison. I can also say it's during this time period and save this note. This now goes to Allison. Allison will be notified that I just sent a note to her. And then what the system can do, once this saves, it can overlay the time period on top of the chart. So real nice capabilities where once you create a note and tag a user and assign it, it can overlay on top of a chart. The other thing the tool can do is build out correlations. So we were just looking at an example of use versus production. And maybe I say, well, visually, it looks like my consumption, in this case of HVAC, is correlated with my production. But how about we build out a statistical model and see if it's in fact correlated? So that's what I'm doing here. There's a formula composer capability in the tool that lets you, in this case, I'm just saying, let's plot on a regression model my consumption and production and see if there is a statistical correlation. And in this case, it's saying, yes, overwhelmingly there is 97% correlation. So we can build out, you can build out regression models. You can use this to create virtual points. So I could create a new point in the system based on, the fact that now I'm comparing use versus production. And that can always be something that I monitor. And then this can create Sentinel views and some other analysis. So some really powerful tools when you want to do comparisons or virtualization. Some other tools that are really useful, one of them is a heat mapping tool. So what heat mapping does is it allows you just to have a look at how your building or point, whatever you're monitoring is performing. And you can see in dark, like when your highest periods of consumption are, and in light when your less period, like your less intense periods of consumption are. What I can tell from this maybe is, we have some consistent patterns, certain days of the week, it's not really operating, so we're not manufacturing those days. But notice that some of these days, my pattern seems to be more intense, in the evening hours. And let's say that these are off-peak times. So everyone's going home for the day, but I still have a few days where I have some higher consumption. Well, that can be a problem. So what you can do up here is run some what if scenarios. So I could say, well, what if I have a deeper setback? Let's call it a 70% setback. So deeper setback in the evening hours. If I could do that, how much would I save? So I can change the heat map, run a hypothetical. And now I'm saying, well, if I can make that type of scheduling change or equipment change, I could potentially save 12% for the month, which then translates to 1,400 euros. Now, how did I get the cost? Well, there is a tariff engine in the system. So you can build time of use tariffs based on any currency. You can also apply CO2 emissions to get your CO2 data. So in this case, I'm saying, well, I would save from a consumption standpoint, 3,500 kilowatt hours. But from a cost standpoint, I would say 1,400 euros. I can also look at what I might save from a CO2 standpoint. So from a CO2 standpoint, what would be my potential emission savings similar to the use and cost values? So some really nice capabilities to run some what ifs. Now, if you are implementing projects, there are some deep analytics to track savings. So what does that look like? So there's an M&V engine, a measurement and verification of savings engine that does option B and option C savings protocols, where you can walk through a project, give it details, it'll create a model and then calculate your ROI. So in this case, we're using option B. We're saying that the cost to change a piece of equipment is $15,000. This is the actual ECM or energy conservation measure. You establish a base metering period. You establish a reporting period. You can then create routine adjustments. So do you need to take into account production, hours of operation, heating, cooling degree days, days of the week, things like that. And then the system creates the model. So it's multivariable, single linear regression that's looking at weekdays, weekends, and factoring in, all these factors. You then get the comparisons. So this screen is dedicated to that, where this all is showing your pre-energy conservation measure period. The red is the model that we just created. The green is the actual metered consumption. And then this period here in pink is the period where you implemented the project. And then the post is showing your model versus your metered. And the reason we overlay it like this is so visually you can see, is the model, reasonable? And in this case, I'd say besides this one little point, yeah, absolutely, the model is very reasonable. So what it's telling me here is if I continued forward and did not do the ECM, this is what your pattern of consumption would be, but the green is the actual metered. And then down below, it's telling me, what my savings per year would be, which is this. Total kilowatt hours projected based on these calculations, and then what my dollar savings would be and what my payback period is. So some really nice tools to actually calculate savings. Okay. Last thing I'll show here before I shift gears a little bit is dashboarding. So as I was showing earlier, you have some really nice charting capabilities, point and click capabilities where you could just click on, different meters or points and, filter over time periods. You could overlay weather data. You can look at CO2 values instead of use or cost. So a lot of different ways to, look at the data. Now, let's say I like this view and I want to save this view. I can click this plus button here and then give it a name and some other filters. And what this will then do is add it to my dashboard. So the system provides dashboarding, and these are dashboards in real time. So some of these widgets, like this one in the top right, it's showing real-time data as it's coming in today. Other widgets I've set up are just point in time. I'm telling it the very specific time period to display. So you can create however many of these custom widgets you want, and then the system provides a URL. So what's nice about that is you can then share your dashboard with others. You can embed these in websites and just do a lot with the data now that you have some visuals. Okay. Hopefully you appreciate this tool. This is our Smart Analytics tool. Connects to various systems or hardware to help you monitor and track data in real time. We have some other tools that are very useful as well. So one of them is a utility bill tracking tool. So what this allows you to do, again, using a hierarchy structure, you can set up how your organization is structured. So maybe by division, and then by region or by country, and then you have your plants, and then you have the commodities that you're getting billed. So what this is tracking, if I click on this electric meter, it's tracking the actual utility bills that you would be receiving. So this is showing all of these bills. I can bring up a bill record. You can see all the different types of line items, on-peak, off-peak charges, on-peak, off-peak demand, whatever you're getting billed for from your utility can be tracked in the system and then reported on. You can link to bill images. So if you have the entered bill record, you can track images as well. And there's numerous capabilities to do bill entry. You can enter bills manually or import them, or we have a service we call bill capture. We can get bills from any of your vendors in a lot of different methods and a lot of different formats, PDF, Excel, paper, EDI, and then process them into the system on your behalf. So a lot of different ways to get bills in. Now, as bill data comes in, there's auditing that gets flagged on bills. So this, a lot of different checks that can be run on bills. And some of these checks are like the Sentinel I was showing earlier. They're predicting your use, demand, and cost charges using machine AI. So we're doing the same kind of modeling on utility bills as we do with interval data. So the auditing system can also audit against that prediction model. And then any bill that would fail one or more would be flagged with this red flag. And then you can go in and kind of visualize what's going on. And from there, add notes, assign bill flags to users, add notes and keep track of all your activities related to resolving bill-related issues. So a lot of capabilities here. This does a great job at rolling up data. So I can click on Division 1 and get rolled up summaries of total cost for all commodities and look at all commodities rolled up, electric, gas, really any commodity that you're getting billed for, water, trash, recycling. The system can track really anything. And so here's a look at all the different types of commodities that at least this database is capturing. So, internet charges and gasoline and various other things. It can connect to Energy Star. So if any of you have the need to, for compliance purposes, you can submit your building data to Energy Star. So you connect to your portfolio manager account, and then you can automatically submit your buildings. And then if they are rateable, it will return the ratings for the buildings. Additional benchmarking capabilities include a group manager, where this lets you set up peer groups of buildings. So in this case, maybe a group of all of the manufacturing plants, and I can look at benchmark details based on a cost per area basis or maybe a use per area basis. You can also track production, as I was talking about earlier. So you could track your use per production for all of your plants and just see what the values are. So some really nice tooling that lets you take data from wherever it's located and benchmark and compare it with one another. There's the capability for running reports. So libraries of reports that lets you say, what type of report might you want to run? And you can visualize a sample of the report and then set filters and then, run the report to a couple different formats, PDF, Excel, Word, and then you can run the report and view it. For those of you that like to get fed data, you can set up report distributions. So you could say, well, here's the report I want to run based on these filters. And then you can set up an email and content the message however you want and list when you want the reports to be pushed out, daily, weekly, monthly, yearly, to various stakeholders, and the system will automatically email out reports. So real nice way to get data in the hands of your users. And here's the look at one of these reports. This is showing the divisions set up in the database summarized, so aggregated data at the divisional level, and then comparing each division against one another from a EUI standpoint, so normalized use per area. And then also comparing that division against itself over a 2-year period. So that's an example of a type of report that can be run. There's dashboarding capabilities. So you can set up however many dashboards you want. This is all, again, based off of the bill data. So you can set up dashboards similar to what I was showing earlier with the Smart Analytics tool. You can also share links and then open dashboards outside of the application. So you can embed these into websites, share with users, and they can bookmark them, but then access the data and look at a lot of higher level content and real-time data just via dashboard. Some other capabilities regarding carbon emission reporting and carbon accounting is as you're tracking consumption, either if it's metered consumption or you're getting it from a bill or you're getting it other ways, and I'll talk more about that. When you're tracking your various usage, you can apply your carbon emission factors to calculate your CO2. So we as a service, as part of our Carbon Hub application, we provide access to greenhouse gas emission factors from EPA. For electricity, it's using eGrid, and then a bunch of other factors for other types of commodities and purchases. We also provide international factors for any of you international folks out there that's outside of the US and North America. So the real trick is you need to track the consumption, apply factors. So in this case, with eGrid, it's showing all the different gas types that go into the total equivalent CO2. For any one of your points, you can select what is the scope category, and then what is the factor I want to use. So down below, you can create your own custom factors, or you can select from one of the numbers of countries and lists that we have set up in the database. So part of the exercise is identifying what all you need to track that would go into your carbon reporting, your carbon report, and then set your scopes and then set your factors. So hopefully you can see here that we have air travel that we're tracking and mass transit and ground transportation. You can track renewable energy credits and RECs and offsets. So you decide what resource or commodity you're tracking, what scope category it is. So for these scope 3, we have all of these set up in the system for all of your purchases and things you're producing. So you can set all of those categories and then set whatever the default factor is. Again, using our library or ones that you create on your own. So for all of your main core commodities, you just enter bills or enter meter data, and then the carbon data can populate. So this is showing for this electric meter, total equivalent CO2 this year versus last year, year-over-year trends. And you'll see this throughout the application. You can set reduction targets and see how you're comparing the targets. Throughout all of our applications, you can look at the data, the images in greater detail, download the charts, and also export any of this data that you see in any of these charts. And this carries over in every single chart throughout the app. For those of you that are working on your carbon emissions reports, you can track, I had mentioned earlier, scope 3 emission categories. And so what we're seeing for some of our clients that, in the case where they need to start tracking scope 3, maybe they're tracking things like air, total miles flown, and you can apply greenhouse gas emission factors or carbon emission factors on the miles. Well, at least here in the US, the EPA puts out cost emission factors. So in this case, what this client is doing is saying, well, every year we can at least keep track of how much we're spending in air travel, so 81,000, and then the EPA provides a CO2 emission factor that is taking into account cost of air travel or lodging or meals and entertainment or other travel or those kinds of categories to get your CO2 emissions. So we realize there's regulations that are starting to come out and being developed by the SEC as we speak. But there's tooling in here to help you on your journey to start reporting your carbon footprint, if you have not started yet. So again, you can track consumption and apply factors. You could also track cost and apply factors. The other thing you can do is you can track things like offsets and RECs. So if you're doing any types of purchases, you could track what those purchases are and then track the negative impact to CO2, and then that can be applied. So if we go up, say corporately, we can look at our total carbon emissions year over year compared to targets, how that total stacks up, scope 1, 2, and 3, look at how each scope is performing, look at which buildings are the worst emitters, compared to the others, and so on and so forth. And then that carries into dashboarding as well. So you can look at your data, your greenhouse gas emissions data, a lot of different ways. You can select widgets and display them on dashboards, and then again, share them with others. Last thing I'll mention is mapping. There's mapping tools that let you look at, your buildings on a map. So you could look at an aerial view or a satellite view. And then every building can be scaled based on different types of metrics. So maybe I want to look at the buildings that are the worst from a CO2 emission standpoint. I can click on that building and then get some KPIs. And again, these maps can be shared with others and displayed on websites. Well, I hope you enjoyed the presentation today, and I hope you understand the value that our tools would bring to really any organization that is tracking energy. We really look forward to engaging with all of you individually, and I hope you learned a lot today. Please visit our website, www.energycap.com, and please engage with our sales team. Feel free to email us at sales@energycap.com to schedule a consultation with you to talk about your specific needs. Thank you very much, and goodbye.